Team 928026. A big round of applause, please.
Hi, how are you today? By the end of this presentation, one more Indian farmer would be dead. In Britain, a farmer commits suicide at an average of once a week. But in, but in India, every 32 minutes a farmer dies. That's very unfortunate. Right. Well, that's very unfortunate. According to the National Crime Record Bureau of India, 256,000 farmers have died since 1997. That's past 15 years. That's 17,068 in per year, and it's 47. That's each day. Now we have to understand that farmers are backbone of our economy, and we have to take care of them like our own brothers and sisters because they are the ones who provide food on our table. So where's the problem? The problem is debt. Farmers are forced to borrow money from financial institutions because the cost of cultivation is rising up. And why is this cost of cultivation rising up? Many reasons behind that, but the ones which we are mainly concerned about is overhead expenses. Now the overhead expenses like renting pump set, relying on electricity, and buying diesel for generators. Now our design specifically is targeted to solve these three problems. Now you might tell me that it's not such a big problem. Irrigation is not such a big problem. But in 2002, my geography teacher taught me our nation is 70% dependent upon monsoon. It's 2012 now and nothing has changed so far. Price of the diesel, rupees 51 per liter. There is no way a poor farmer and his family could afford diesel at this price. And what about electricity? Electricity is a life for rural India. So what should be the solution? What should be the characteristics of the solution? And how it should be? Very first thing, our solution should be independent of fuel and electricity. The second set of challenge for us was that our solution should be easily available in local market. Solution should be affordable, not too hard on your pocket. It should be easily acceptable by the society. A recent report says that every family in rural India has at least one or more bicycles. And also scientific experiments have proven that force of human legs is 5 times stronger than the force of human arms. The third set of challenge for us was to build something which is easy to build something which is easy to fix. Even a layman should be able to fix it if something else goes wrong. Build something which is easy to maintain, zero maintenance charges, and build something which is easy to cook. It should be mobile. Now, how many of you in this room did ride a bicycle before? Please raise your hand. Well, that's a good number. Bicycles are fun, isn't it? So, the big idea is to come up with a mobile bicycle pump, and we call it the Buddha Pani. The idea behind this is the energy is taken from the rear wheel of the bicycle, which runs the pump. The whole system is made up of water pump, iron frame that is built upon a bicycle. Simple, very, very simple, yet very efficient solution. And here is how it works. To start the pumping mode, we just have to rotate the frame 180 degree down, because of which the traction is developed between the bicycle car tire and the rotor. Now this traction can be fine adjusted if we move the motor on the rails, because of which now when a rider rides the bicycle, pump will draw water from one side and pump from other. Once you are done with the pumping, just rotate the frame and roll on. So here are a few specifications. An average rider can pump up to 17 liters a minute, which makes 1020 liters per hour from a 350 watt pump. That's a good amount of water there. It can pump up to 13 meters of water up to 13 meters of height. So water can reach up to G plus 3 level. It can draw water from a maximum depth of 6 meters. Maximum pumping distance is 150 meters for one pump, although one or more pumps can be connected serially and this distance can be increased further. One pump at one time can irrigate 2.4 acres of land. Now in India, average farmer owns around 3 to 6 acres of land, average low income farmer. So with this, he has to irrigate, he'll have to just use it around 2 to 3 times to irrigate his whole field. Now let's talk about the money. If you want to build this bicycle at home, it will cost you 5,350 rupees, which is 3,000 for the bicycle. Cost of the pump would be 2,000. Production cost, which should include angle iron and welding, would be 350. Total cost is 5,350. Now, if you already have a bicycle at home, you don't need to go buy a new one because our system can be made upon any old or new bicycle. Even if you have a broken water pump, we can use it. I'll tell you in a minute how. So, if our system is manufactured in bulk, the price would go down up to 4,200 rupees. Here's how. Cost of the standard bicycle in bulk will be 2,900. Cost of the water pump would be 1,200 because we are using only the mechanical portion of the pump and not the electrical portion of the pump. Production cost would go down up to 100 rupees. So the total cost will be 4,200 rupees per bicycle. And guess what's the cost of usage, people? It's nil. Oh, you don't have to read these slides. Just look at me. I'll tell you what's there. The materials required are things we require is a bicycle, a centrifugal water pump, and angle iron. Some tools that we require would be welding equipment and few paints and everything. First thing, we have to take the angle iron, cut it, bend it, and make a frame. The frame should be of size 30 centimeter wide, 40 centimeter length, and 22 centimeter height. Next step would be to make this rails, which I talked about. On these rails, the pump would move and we can adjust the friction. Now we are done with the frame. Moving to the motor. Cut out the electrical portion of the motor. We are using only the mechanical part. And we have to tie a rubber upon the rotor of the motor to increase the friction between the bicycle tire and the pump's rotor. And assembling everything down, we are done. It's pretty easy. Our system is independent of electricity, petrol, diesel, gas. It's also independent of any kind of seasonal and climatic variations. Easy to build, easy to move, easy to maintain, fix. It can be built upon any older new bicycle. Easily available, acceptable, sustainable. It's very eco-friendly, no pollution. It's also very user-friendly. Now, the important part is our bicycle will encourage rural women to ride on it because it can be also used for domestic and household purposes, like drawing water from a well or putting water to an overhead tank, etc. So, here's my dream. There has always been and will always be a continuous need for water supply for irrigation and domestic purposes. Now we plan to make 10 more sets of this bicycle initially and then millions after. God bless, wish us luck. Thank you and Jai Hind.
Questions from the judges?
Use this arrow or use this.
All right.
Where's the rest of your team?
Sorry?
Where's the rest of your team?
Ma'am,
Do you have the prototype of this? Have you attempted to make?
we are building the prototype, but we are not finished yet because of that situation. Else we would have brought the prototype over here.
Excellent.
And one more thing, it's gone. All right. Me and my friends are building that prototype, and we are planning to carry that, make at least 5 prototypes and sell it to the villages. and begin the second round again, make those prototypes and sell them again. So we are kind of almost done with the prototype, and we just have to, my village and then a couple of villages around, we did a talk, and then we just have to go, and this Diwali, coming vacation, we'll do it.
Well, I think so. You are solving the problem of pumping water, right?
Irrigation, yes, sir. Yes, sir.
Well, that's where I'd like to understand more about the idea. So you say irrigation. So what's the source of water here?
The source of the water should be nearby. Like I said, there are some constraints, but it can't draw water if the water level is behind 6 meters depth, and then if the water is nearby, we can use it. Like the first slide which I showed you, over there was an old man and his girls who were pulling the water from the well. So for a situation like that, it's very, very useful. The very first slide.
Okay. Next question is: you have certain parameters of, let us say, there are distance limitations and the height limitations.
Yeah, yes, sir. We do
and the
have.
depth limitations of water
Yeah.
as well. Have you thought about perhaps a systemic solution where you may have scaling up of these things or connecting, systems together to extend the capability, things like that?
Yes, we like I said that if two pumps were connected in serially, one pump can throw water up to 150 meters. But if two pump is connected serially, the distance would go even further. So now, unless we build an initial prototype and sell it to the people and then get results back from them, we can't just move to stage 2 and building a better +1 prototype.
Okay. And you said your prototype is in the works. Have you done any prototype at all, even at
No,
a model
we
form?
have started.
Or models, for that matter. A model of your solution.
No, I don't have any
No,
model over
okay.
here. I'm very sorry.
No, that's okay. I just want to know your process, how you arrived at the solution, and what kind of a testing you might have done. Have you talked to any of your potential users about this and gotten feedback from them?
We have tested the bicycle by ourselves, and in our hostel there are around 70 of us, so we have tested. It depends upon the rider also, the amount of water that we get. So once we start giving it to villagers, we'll get a better result from them,
Okay.
better input.
All right.
Do we have any more questions?
So, have you looked at what the average water table depth is in the communities around you?
Sir?
What is the water table depth? Like how?
No,
how-
it cannot be used if the water level is too deep. Though it can be used because generally what happens is that water comes from the canal, but still you have to put the concept to get the water and get it irrigated.
So okay, so it's only to use if you already have standing reservoirs of water. That's when you can use this solution. Okay. Okay, thank you.
We get to the audience question.
Do you have any idea whether the farmers are interested in this? Or has anyone tried this before?
Last time when I was here, I did come to my village and a couple of villages around. So they said that yes, they are interested, but we have to show them a physical model over there, demonstrate first, and then they buy. So this coming Diwali, this vacation, we are going over there, we're going to do that thing, we're going to sell that thing.
I'm very interested in your idea since in Japan we had a big earthquake, so we lost the electricity. So I think the saving energy and producing electricity energy is very important also for us. I'm not sure about it. In case in India, you are mentioning about the pump to produce the energy. But in Japan, I'm very concerning about the battery of the cellular phone. I think you can change their electricity.
One job, but couple of things more we can add in that bicycle. Like if you add an electrical motor over it, we can light a bulb. I mean, these things, like we had those bicycles with the bulb in front, right? I mean, not in Japan, but India, we had this thing before. So, couple of more attachments can be added to it, and it will work just fine.
Yeah, first of all, I'd like to appreciate you for your idea. I guess it's still at the conceptual stage. But still,
Kind of building prototype, but yeah.
yeah, but still,
Right
I
now-
mean, you have not done really
Yes.
the concept, the detailed study on that. Just a word of caution. When you're talking about drilling, getting water. Basically, your source is wells, and 6 meters is too low. I mean, nowhere you will get water at 6 meter depth.
I know.
It's much farther down. You may have to go till 15 or 20 meters deep. Okay, just a word of caution on that. And another thing, have you done any analysis like how much water is required per acre of land?
That depends upon the crops and depends upon the field.
Yeah, have you done any analysis like this much of quantity of water is required and for the
That
one?
differs, sir. That differs. But we did tell that how much water it can pump out and what's the distance and other specifications.
So, how much water can one farmer pump out using this bicycle if he continuously pumping for 1 hour? Can you do that?
No, the thing is, one farmer cannot pump continuously for 1 hour. That's an idea which I gave you, 1020 liters in 1 hour. But I mean, it's like pumping for a while and taking a break, and then maybe your brother or something would pump the pipe again.
Okay, so that's now a last question.
Yeah, I think it is in connection with what he was asking. How long does it take for him to really suffice what field he has got? Okay, you said it is nil, right? There's no cost for it, getting the water out. If he does it in limit, he will be healthy. If he is excess, he will be in hospital, which will cost him more than getting the water out than getting admitted to the hospital.
Rural people eat better than us, sir.
True.
Okay. So we'll have one more question.
All right.
And that's really the last one.
I want to know if there is a exercycle version of yours. Then you can sell it in urban areas, and I will buy it and I'll give the energy free.
Thank you very much.
Okay, so thanks, Rohit. So we'll have the next team coming. Yeah.
It will be there.
No. Yeah, this exercise bike that you mentioned exists in Denmark.
So thanks, Rohit. We can have the next team.
Thank you so much.